Uh, hello everyone. Today we are going to solve the next question on bit manipulation. So, in the last video, we have solved one like first question on bit manipulation, and before that, I explained the concept, like basic concepts of bit manipulation. If you haven't watched that, please do watch that video first, and then try solving questions with me. Okay, so today I'm going to solve this question. I have already opened it. Like, check whether kth bit is set or not. Okay, so given number n and a bit number k, check if kth index bit of n is set or not, and a bit is called set if it is 1, and position of set bit 1 should be indexed starting with 0 from LSB side in binary representation of the number. Okay, so let's say an example is this. Okay, so this is the binary representation of a number. Then it we suppose let suppose k is given 3. So how we are going to check kth bit, and from LSB side, that means from the right side. So this is 0, 1, 2, and 3. So this is the third like index, like it is starting from the 0. It is given in the question. Read the question properly, then only we'll try to solve. Okay, so kth means this is the third, like that means from fourth bit from the right side, that is the third, like third indexed. Okay, so we have to check that. So we have different methods to solve this question. We are going to use the left shift and right shift operator today to solve this question. And these are the two different methods. In one method, we will use the left shift. In another method, we are going to use the right shift. So let's solve using first method, that is using the left shift. Okay, so let's say if I take a binary representation of a number, like this is the number, let's say. So if I do AND operation of this both, then what will I get? So we know the AND operation. In AND operation, if two bits, like if any one of the bit is 0, then the output is 0. So here all the bits are 0 except this one. Okay, which is at kth position, at kth indexed. Okay, at third position from right, that is third, like position is starting from 0. Okay, that's why I'm saying it's third. So in at the third position there is only one, like it is a set bit. Okay, so we are going to AND with the other one. If if the initial here n is given, let's say this is n. Okay, and this is the binary representation of a number which I am assuming, or I am considering that number to check if the kth bit is set or not. And at the kth position in the second number, there is a like it is there is a 1. Okay, bit 1 is there. So if we do AND of these two, if the output we get 0, that means in the initial number which is given, there is it is a set bit. Okay, at kth position there is a like bit as 1. If we get 1, okay, because 1 and 1 will be 1. If it is not, if it is 0, then we'll get 0. Okay, so what we will get here, if if this is 0, then we'll get answer as 0. If this is 1, then we'll get answer as this, like non-zero, whatever maybe the number, we don't we don't care about that number. We only check if it is 0. That means it the set at kth position, it is not like a set, it is not a set bit. Okay, and if it is 0, if it is non-zero, then at kth position there is a there is a 0. Okay, so at the end, like 1, what we have to do to get okay, so here what we did, here we got this thing, but we have to find this number, right? How we can find this number? Just take number 1 and do left shift by k times. So here if we have this number, okay, we have to do left shift, we have to shift this 1, okay, by 3 times, as k is 3. So here it will be 1, here it will be 0. then we have to do the AND operation. After doing AND operation, if we get 0, that means we have to return false. At kth position, it is not set. And if we don't get 0, that means at kth position, it is set. Like there is a 1 as a bit. Okay. So what we have to do, we have to check if 1, if n, and we have to do AND operation with 1 left shift by k times. And if it is 0, what we have to do, we have to return false. And if it is not 0, that is non-zero number we get, then we have to return true. Okay. If we run, okay, we are getting the output as correct. If we check with okay, we'll check with this one. Okay, yes. So the first test case was 4 and 0. So here n is 4, k is 0, like 0th position. If we represent 4 in the binary, that means this is the binary of 4. So at 0th position it is 0, so we got no as answer. And like the next test case we checked with is 10 and 1. Binary representation of 10 will be 1010. Yeah, it plus 2 is 10. Okay, and at 1, at first position, like first index, so this is set, so we are getting output as yes. Okay. So the next method, this is the first method we have seen. Next method is using the right shift. Okay. So we have used the left shift. The next method using right shift, how we can like check if the kth bit is 1 or not. Okay. So we have number n, okay, this, and like in the binary, and we are given k is equal to 1. So we are checking this. So if we shift this bit to the right, then we can check the last bit. Okay. Suppose we have this number, and if the our if I shifted this bit to the right, okay, I mean the number by right, so you'll get the last bit as 1. Okay. So if I get the last bit as 1, then we have to check the last bit only, and we know how to check the last bit, right? We can directly check the last bit, and then if the last bit is set or not, according to that we have to send we have to return true or false. Just using the right shift, we have to shift it by here k is equal to 1, so we have to shift by 1. We want this bit, right? And we have to check. How we will check? Either we'll do and with 1, right? So we got this number, and we have to do and with 1. If we do and with 1, then if we get answer as 1, then we can say at kth position, like there is a bit 1, like it is a set bit at kth position. If we get 0, then we have to return false. Okay. This is the next method. What we are going to do here, if, okay, if first we have to do n, okay, n, what we are going to do, right shift by k times, right shift by k times, and what we are going to do, and with 1. Okay. If it is 1, then we are going to return true, else we are going to return false. Okay. So we are getting the correct output, 10 1. Yes. If we check with the initial, like 4 and 0, okay, we are getting no. If I check with 4, let's say 2, it should be yes. As 4 is 100, at second position it's 1. So yeah, we are getting the correct output. Yeah, I'm not going to submit as I already saw it in before, so I have submitted it. So right now I'm only explaining the concept, like how we can solve the question with different methods. Okay, so we solved this question with using which operator. First is AND operator, and left shift and right shift. Okay, and both are very important, left shift right shift, because it makes easy for us to solve the question. If we are not using left shift and right shift, what we have to do, we have to use a while loop. Then we have to divide and divide the number, like using and percent remainder will get. How we suppose you are given a number and you have to add the digits of number, how we find the remainder and divide it by 10. So similarly we have to divide it by 2 and percent 2, then we have to check the, like, it's a big procedure. Okay, like it's a easy only, but still using the left shift and right shift operator and operation, we can solve the question like easily. Yeah, this is the question. Yeah, done with this question. So like this only I'm going to solve different questions on these concepts regularly. If you feel this is helpful for you, then you can like this video and subscribe my channel for more such questions to solve. Okay, thank you.